With problem number 22, we have the integral from 0 to pi over 8 of the quantity 1 plus e to the tan of 2x times secant square of 2x dx. And what we're looking for is function composition, first of all. And do we see a function composition? Well, we have a couple of function compositions here. You have e to the tan of 2x, and you'll also have secant square of 2x. But you're looking for the function composition whose inside function, whose the derivative of whose inside function shows up on the outside. And since we know that the derivative of tangent is secant squared, then that's the clue that we want to let the 1 plus e to the 2 tan x be our, actually just the tan 2x, sorry, be our u, because we need the derivative of that not to be an exponential but to be a secant squared. So I'm going to let u be equal to the inside function of the function composition, which would be tan of 2x. And then du is going to be secant square of 2x times the derivative of 2x, which is 2, and dx. Now you can see conveniently we have the secant square of 2x, so all I want to do is divide by 2, and that helps me solve for secant square of 2x dx. And if I were to go ahead and replace those now, my 1/2 is a constant multiple, comes out. I still have the 1 plus e to the u now, and the rest of it is just the 1/2 du, the 1/2 already being brought out. So that's what we're going to end up with. We do have a definite integral here, so I'm going to need to find what my u limits would be. If u is pi over 8, when x was pi over 8, what would u be? And so we're looking for tangent of 2 times pi over 8, which is tangent of pi over 4, and that's simply 1. Then when x is 0, we would have tangent of 0, and that is 0. So my new limits of integration are 0 to 1. Alright, now we're ready to find the antiderivative. And the antiderivative of 1, that's going to be u. And the antiderivative of e to the u, that is e to the u. Evaluated at 1 minus evaluated at 0. So we get 1 plus e to the 1 minus 0 plus e to the 0. And e to the 0 is 1, so we're going to end up with 1/2, 1 plus e minus 1, which is simply 1/2 of e over 2, and so the answer is B. Alright, so this is a little bit more complicated. We look for the function composition. The inside is not the whole 1 plus e to the 2 tan x, because its derivative would then be e to the tan 2x times secant square of 2x. It's not going to work when we swap out as cleanly as we did here. So the inside function is simply the simply the tan of 2x, and its derivative secant square of 2x, or a constant multiple, shows up on the outside. All right, we'll stop this video here.